Today we're going to calculate the inverse of our matrix using the third method, the determinant. Don't forget what we've done in the two previous videos. We calculate the inverse of our matrix using the first method, the definition, and also using the second method, the Gauss method. On this occasion, we're going to calculate the inverse of our matrix using the formula of the determinant. Of course, depending on your studies, you will be required to calculate the inverse of a matrix using one of these three methods, or perhaps the three of them. Anyway, you are in the correct place to calculate the inverse of a matrix. Let's go.
Binnacle Project.
I hate teaching things and asking you to learn them just because a formula says so. I'm afraid that this is one of these occasions. This is the formula that would lead us to the inverse of our matrix A. Look. First of all, we are going to calculate the denominator of this expression, that is, the determinant of A. Why? Not only because it is necessary, but because if this determinant equals 0, our matrix will not have inverse. Don't forget, when the determinant of a matrix equals 0, the matrix doesn't have inverse. Got it? On the second hand, we're going to calculate the adjugate matrix of A. It will be very easy. And we will transpose it as the formula says. Ready? So, let's begin calculating the determinant of our matrix. When you're calculating the determinant of a matrix, we use vertical bars, okay? And here is a matrix. 1, 0, -1, 2, -1, 0, 2, 0, -1. And let's go ahead. First of all, 1 times -1 times -1, that is 1. Now we move to the upper right corner and we do 0 times 0 times 2, that is 0. And finally, we do -1 multiplying these two positions. -1 times 2 times 0 is, of course, 0. Okay? Second part. Now it's time to do 2 times -1 times -1, that is 2. And we move to the upper left corner. 2 times 0 times -1, 0. And finally we do 1 multiplying these two zeros. 0, of course. And if you do it slowly, here we have the result. It is -1. Luckily, this result is not 0. If it was 0, we should stop the video and say that our matrix doesn't have inverse. But as it is not 0, but -1, the party continues. As I ran out of space, I noted here the result. And now it's time to calculate the adjugate matrix. How are we going to do it? It's very easy. First of all, let's write our matrix. 1, 0, -1, 2, -1, 0, 2, 0, -1. And let's say that we're calculating the adjugate matrix. And first of all, it's going to be an order 3 square matrix as our matrix A. Tiki, 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 taka, taka, taka. And how are we going to calculate the first position? Row 1, column 1. Look, we have to remove precisely row 1 and column 1. Let me do it with my hands. Can you see the positions that remains? We are going to calculate the determinant of these positions. It will be an order 2 determinant, okay? Let's do it. -1 times -1 is 1, minus 0 times 0, that is 0. The result is 1. Okay? It's as simple as repeating this procedure all the time. Let's calculate the second position. Row 1, column 2. So let's remove row 1 and column 2. Row 1 and column 2. Can you see the remaining positions? Let's calculate the determinant. 2 times -1 is -2. minus 2 times 0 is 0. The result is -2. -2. Third position, let's remove row 1, column 3. Row 1 and column 3. Can you see these 4 positions that remains? Let's calculate its determinant. 2 times 0 is 0. Minus 2 times -1 is -2. 0 minus -2 is 2. Okay? If you want, you can stop the video, try to do it by yourself, and let's check if we have the same results. Let's go on. Fourth position, row 2, column 1. So let's remove row 2, column 1. Can you see this determinant? 0 times -1, let me, it's a bit complicated. 0 times -1 is 0, minus 0 times -1, which is also 0. The result is 0, okay? Row 2, column 2. Let's remove row 2 and column 2. 1 times -1 is -1, minus 2 times -1 is -2. -1 minus -2 is -1 plus 2. That is 1. Be careful with the signs, okay? Let's go on. Row 2, column 3. Row 2, column 3. That's it. 1 times 0 is 0, minus 2 times 0, also 0. The result is 0. Row 3, column 1. Row 3, column 1. 0 times 0 is 0, minus 1. 0 minus 1 is -1. Row 3, column 2. Let me rewrite this. Okay. Row 3, column 2. Row 3, column 2. 1 times 0 is 0, minus 2 times -1 is -2. 0 minus -2 is 0 plus 2. That is 2. Okay? And finally, row 3, column 3. 1 times -1 is -1 minus 0. -1. That's it. These numbers that you can see here doesn't still form the adjugate matrix. These numbers are the so-called complementary minors. Complementary minors. How can we become these complementary minors into the cofactors? Because the cofactors will finally form the adjugate matrix. Well, you have to use the snake, okay? The snake. What are we going to do? We're beginning with the first position, position 1, 1, and we are moving like a snake, okay? Like a snake. And we are going to say positive, negative, positive, negative, positive, negative, positive, negative, positive. When we are saying positive, the number doesn't change its sign. But if we say negative, we will change the sign of the number, okay? Look, positive, negative. So let's change the sign. Let's go on. Positive, negative, 0 doesn't have sign. Positive, negative, positive, negative, and positive. Don't forget, when I say positive, I maintain the sign of the number. But if I say negative, I change the sign. And finally, after passing the snake, here are the cofactors. These numbers that you can see here are the cofactors of our matrix. And the matrix of cofactor is the so-called adjugate matrix. So now it's time to present the solution. Let's say that the inverse of our matrix is the adjugate matrix, here it is, but transposed. Don't forget this little important detail, okay? So let's take the first row and turn it clockwise to form the first column. 1, 2, 2, but in form of column. 1, 2, 2. Easy, right? Let's take the second row and turn it clockwise to form the second column. 0, 1, 0. And finally, let's take the third row and turn it also to form the third column. Divided by -1. And this is the result, but I'm sure that you are considering that all these positions can be divided by -1, which is basically to change the sign of all these 9 positions. So our inverse matrix will be -1, 0, 1, -2, -1, 2, -2, 0, 1. And that's all. The first time you use this formula may seem a bit complicated, but it is not at all. This is a procedure I always use when I'm calculating the inverse of a matrix, so be patient and try to repeat the exercise in order for you to achieve this result. And now it's time to rise the temperature of our thermometer, so let's go with more complicated exercises. See you soon! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!